All right, good morning. This is Mark Rankin. I'm the creative director of the CAP department. I'm here to tell you a little bit about Lamar Graphics 3D division and how we're on a mission to break those plain old planes in every direction. Before we get started, I'd like to tell you a little bit about the background on how this division came about. Sometime in early 2012, two things set into motion the LG 3D division. The first thing being the OAAA rebranding. They focused on several of the outdoor strengths and weaknesses, and they identified three main spike attributes: innovation, ubiquity, and creative impact. Now, creative impact we can have a lot of control over, especially here in the CAP department. And that's when Bobby Switzer instituted the Great Extension Blitz of 2012. Basically, what this was is CAP put an extension or two on every vinyl billboard design that came through the department. And that is a significant amount in a month's time. So we really littered the department with, or the industry and the plants with a lot of extensions. What we learned during this blitz is the AEs were really starting to push back on these extensions. They wanted us to stop sending them altogether. We were really curious as to why that could possibly be. It's just a little bit of an artwork enhancement. But it turns out many of their operations crews were discouraging the account executives from selling extensions. We were kind of curious about that as well. Why would the operations crews push back so hard? And the more we dug into it, the more we found that the extension building process was really time consuming for the operations crews out there. They were having to wait or even waste a day building extensions instead of hanging copy. And building those extensions could be costly, and it was just a pain for the schedule. It was hard for them to keep up. So that's when Charlie kind of came up with the idea of building all the extensions here at Graphics. Charlie thought of quite a few different techniques that we could use to actually help the plants out and remove this friction point. One of the first things that we ran across is the size of extensions. They're pretty large, and we have to figure out a way to shrink them down to get them from Lamar Graphics to the plants. So with that, Charlie actually came up with an idea to make it a little bit more affordable. He came up with an idea of cutting the backing into an accordion cut so that it would actually it could fold up and make the shipping method much, much smaller. So what about the bracing? The bracing, actually, he came up with a pretty good idea for the bracing as well. What if we put it together like in an erector set? All the metal pieces could actually screw together or come apart so they can be assembled or disassembled as needed. So now all the parts could come apart and we can put it into a nice, neat little pile. And as a matter of fact, that whole thing could fit in a box. And that was the key to making this affordable. So the initial issues that we came across were we needed to reduce the labor and the time needed to build these things at the plant level. We wanted to take that section of labor out of the plants and into Lamar Graphics to save them a day, possibly on the install times. Also, buying materials in bulk, if we tie all the extension material from the entire company into one area, we can get some serious buying power and leverage out of that order. So shipping is a lot less expensive than freight. So with the ability to box them all up and send them on their way, we could save a great deal and still be cost effective. Will be the money that we're saving on the plant's building and the price break with the shipping as well. It's pretty much a break-even process, so it's no more cost to the plants than building it themselves. And one of the biggest advantages, we can deliver with the vinyl. So now you're not waiting an extra day to put the extension together. You can actually have the kit and vinyl delivered at the same time and get the copy up on the street much faster. And lastly, the mast legs and hardware were being shared between plants in most cases. There wasn't enough extension hardware to go around. So now the mast legs and hardware are included in the kits, and we are distributing those pretty heavily for the first part of this year in getting those materials out to the plants. So with all those issues addressed, it was a sound idea, so we broke ground. And so began the new division of Lamar Graphics, known as LG 3D. All right, the first product line I want to talk about is the extension kits. This product line has become wildly popular. When we first started doing this in 2012, we were doing like 40, 60, maybe 100 a month. This year in 2014, July of 2014, we did 170, and that's typically a pretty slow month. So I want to kind of go over just go over the entire process to give you a better understanding and how to avoid some common pitfalls and mistakes that we don't typically catch. Each day, Circle Graphics will provide us with a composite for each one of the extension kit orders that come through, and they'll give us the full board with extensions in place, the board with bleed, and then the individual extension files. So this kind of gives us an idea of all the different elements that go into each board. The first thing we do is Christy and Laura are the pre-press techs that manually put these vector paths in the file. So this is not an automated process. These are actually done by hand several times every day. So the kits are actually, or the router outlines are made manually with the Bezier tool in Photoshop, and they're usually outlined just a little few pixels inside the extension perimeter. This will prevent the backing from showing in case the vinyl, we want to make sure that the vinyl covers the entire set of the backing, and we have to make these paths as clean as possible. Whenever there are side extension or corner extensions, we'll always build them so the horizontal cut line will extend across the top or the bottom. So it builds a stronger extension kit that way. Now, Christy and Laura are actually looking for different shapes as they build these things to nest them within the 4x8 sheets of Coroplast. We try to reduce as much waste as we possibly can, and this is done so we just build these shapes and keep them on the artboard until they start finding some that that fit closely together. So this is they play a game of Tetris basically every day, trying to fill these boards as much as possible and as efficiently as possible. So now I'm going to show you just a little video of how the routing machine works and how the backing is cut out of the Coroplast. The tech starts out with just loading a piece of Coroplast, then sets the vector cutting path to run. The tech will hold down some of the pieces while it cuts. This will keep it from jumping around and causing any miscuts. Now, once the cutting is done, each piece is ordered. The order number and the piece number are put on each tile, and the waste is set aside on a pallet to be recycled later on down the road. Now he cleans off the table, removes the pieces, and gets it set up for the next sheet. So each sheet is then put in place, and the same procedure starts all over again. And you can see here that with the video start picking up speed a little bit. And this process happens over and over and over several times a day. At the current pace that we're working now, this is happening anywhere from 25 to 50 times per day. The next part of the process is the metal framework fabrication. So the first step is the retainer, and that's placed along the bottom edge of the board. And the guys cut it to length, apply it to the bottom edge, install it. Then the heavy gauge framing pieces are used at the tile seams. These are where the tiles are going to bolt together, so we need a little extra strength. Now the rest of the bracing is fabricated, and they'll go around the perimeter, and then they'll fill in with the upright bracing. Everything is cut to length and put in place. Now they measure off every 3 feet to let the ops crews know where the L brackets and mast legs will be attached. Now that the bracing is disassembled, outlined, and numbered. So each piece has a corresponding number and area. And now the last thing is the accordion cuts. Now this one he's cut every 9 inches in the backing, so it can fold up and be no more than 9 inches wide, and that way all the materials and the backing itself will fit into a box. He puts in all the pieces, the hardware, and the instructions, and we're shipping the box. Alright, now that you've seen the process on how they're fabricated, I want to show you a little bit more about the anatomy of an extension kit, and show you all the components that go together to make these kits. The first part is the angle iron. We make the kits out of 1 1/4 by 1 1/4 framing and a heavier weight 2-inch by 1 1/4 framing. Now the perimeter is usually done by the 1-inch, the smaller framing, and the seam pieces or support areas are done in the heavier gauge. The next part is the retainer, and the retainer sits on top of the board face, and that actually sits right on top of the board panels, and then that's held in place by a J-bolt attached to the mast leg. So it's tucked in and pulls the extension to the board itself. And the Z-brackets. The Z-brackets attached to the stringers, and these are the attachment points for the mast legs as well. And those can be put in anywhere along the stringer as long as it doesn't run, close to the uprights. And lastly, the L-brackets. L-brackets are used to connect the mast legs to the top of the extensions. And these have a sliding hole on the side so they can adjust to get the pitch of the extension as flush as possible to the panels. And lastly, the mast legs. Mast legs are they're used to connect all these pieces and connection points together. And they're 7 feet long and can be spliced together with a splicing bracket to make them even longer, depending on the size of the extension. Side extensions work the same way. They're all built out of the same materials, but there is an additional bracket used to attach these. We've included a C bracket in the assembly so that these mast legs can be pushed out side to the side, off the side of the boards, and they can be assembled in different angles as well. The C brackets have 6 holes on them so that you can use them in combination to get the angle that you need. Now there's a couple of things to keep in mind when designing for extensions. A mast leg is needed for every individual extension and every 3 feet for anything over 5 feet wide. So on a board like this, you're going to be using quite a few mast legs and retainers. If you look at the top right, each one of these letters or each one of these groups needs a mast leg to be supported, even if they're really small. And also you'll see that the retainer, that 3 inches that comes up on the retainer, is showing or would have to be trimmed for these extensions. Now modifying the extensions a little bit can save you a lot of time, or your ops crews a lot of time and headache. Grouping these extensions together, especially on the top left one, we're using fewer mast legs, and it's a stronger extension because the backing is wider as well. And you can also see on the other two that the retainer isn't showing nearly as much. If you can avoid cutting into the retainer, try to do that with your extensions. Now, things to keep in mind when you're setting up your art for print. Extensions do print on white. This job here, for an example, is flattened when it comes to us. So when we're sent the extension files, it's pretty easy just to grab that black line and then create your path around it. But what we didn't know is that white space around there needed to be shown and needed to be included on there. So these had to come back and be recut. So if you do have a white or light color on the outside border of your extension, please put a stroke around it. Also, extensions they have to have hard edges. They can't have soft edges like this. This was another one that came in through. Basically, Christy and Laura have to kind of guess what you meant by the edge of extensions like this, and then they'll just draw the path around there and give it their best guess. Extensions also can have cutout areas. That is possible, but the thing to keep in mind, framing will show in some of these areas. Luckily, in this job, the background was white, so it was pretty easy just to fill this back in and have it printed without the cutout, and it fit into the design really well. Now, Another thing is extensions can be too small. This one was only 30 inches wide with some really sharp points. The problem with this is the routing bit is about a 1/4 inch wide. So the green line on the right kind of shows you what a 1/4 inch is to an extension this size. And you can also see that it doesn't go into those really fine corners. It just can't reach it when it's cutting the perimeter like that. So you can't get too precise on those inside corners. Okay, the next product line I want to talk about are pop-outs. And some of you may ask, what is a pop-out? So this is a pop-out. Pop-outs are flat extensions that are installed off of the face of the board. So they're set out quite a few inches, anywhere from 18 to 32 inches out from the face of the board, mounted on some brackets that are built from the framing that we use for the extension kits as well. So this is kind of an example of, I think this one was set out about 20 inches from the board face. Now, what makes these pop-outs grab your attention is it's kind of acts a little bit like an optical illusion. Whenever you're driving by these pop-outs, they make the board move a little differently. They move in a way that your eyes don't really expect, and it kind of draws your attention. Just like these images and these 3D faux 3D images that you see on the screen. They just move a little bit different. They don't move like you quite expect, so it kind of draws extra attention to the board itself. Now, extensions or pop-outs can be put in and displayed on multiple levels. This one, the $100 bill stack, was set out close to the 32-inch range, and then it progressed from there, 24 and 18 for the smaller one. So you can put them in on multiple levels to give a little bit more dimension to your props. You can also do special effects with the pop-outs. John in Little Rock actually installed some spangles and stuff on this one to really catch some attention to it as well. And they put some backlighting with the LED lightings behind it to really make this thing stand out at night. So there's no way to drive by this one without seeing that effect. You can also use the pop-outs in conjunction with other extensions and wraps. And you can see on this board, Mr. Moneybags is a pop-out, while the coins are an extension, bottom extension, and pole wrap as well. So they work really well in conjunction. This is another good example of how well these things or a pop-out can be used to a great effect when on the right creative. This is one of my favorite ones. It just looks really good out there on the streets. And just getting those nice hard shadows when the sun's shining on it just right really makes these products stand out, and they really do pop out as you're driving by. Now I want to talk a little bit about the anatomy of a pop-out. We actually use the same framing, same materials as extension kits, but we trade in the retainer that you normally see along the bottom for other tiles and brackets. So these are built to assemble together with a heavier gauge framework, and then the pop-outs are sent with these brackets that attach to the face. Now these brackets the bracket feet will fold up to make them smaller, make them a little cheaper to ship as well, or shipping friendly, I should say. Now the brackets connect to specific areas on the framework of each of the pop-outs. So as we're building them, we do indicate that on the back of them, back of the panels, where you should install the bracket and what direction the bracket foot should be going in. The brackets themselves can attach directly to the panels. Just drill a couple of holes in the panel faces, and they bolt straight to it. They can also be bolted through mast legs as well, depending on the weight of the pop-out. The larger ones might need to be reinforced a little bit more. Now we did come up with a new technique to alleviate the use of some mast legs with these new brackets with extended feet, with extension supports. We use this on the Miller Lite can bottle things on that extension, so we could kind of avoid using the mast legs with these as well. As far as we know, this has been a successful adventure. Now that we know how they are created, I'm going to show you the pop-out fabrication and installation procedure. Each of the pop-outs is built here at Lamar Graphics, and we are fully assemble the entire piece. Once it is completed, we'll put the bracket location and direction indicated on each individual panels. After the panels are assembled, we apply the vinyl. The adhesive is rolled on, let dry, and then the vinyl application begins. Once the vinyl is put in place and successfully applied, we'll cut the seams, the tiles apart at the seam, and get them ready for shipping. Each of the hardware and brackets are boxed up. The panels, the panel tiles themselves are palletized on the bottom, and the other areas are stacked up on top. Shipping, some of these have to be shipped in multiple pallets depending on the size. We'll build the crates to whatever size is needed to protect the pop-out during shipping. So once it arrives at the plants, the plant operations crew will do some pre-assembly, and they'll lay out the different areas that they need to get it out there on the streets. Once it's out on location, the brackets are attached to the back as well, and those are also used for lifting points on this one. Now the pop-outs can be lifted in whole or in part. It really depends on the extension, or it depends on the pop-out itself. The larger they are, the more difficult it is to lift it in a single piece. Once they get it into position, it's lifted into place, and the brackets are attached to the board themselves. And we do have a minimum size of 18 inches, and that's to allow for the drills for the ops crew to fit behind there. It gives them enough room to get the drill behind and screw the bolts in or drill the holes as needed. So the brackets are positioned within arm's reach all the way around the perimeter of the pop-outs so that we can get back to them. Once the base is put there and installed, the panels that require mast legs for extensions and things like that are put on last. And on here, the head and the wrench did require a mast leg, so they were installed as well for the support. And this is the ops crew supporting the last of the support files, and they get to take a picture and strike a pose. So there's a couple of things to keep in mind whenever you're designing for a pop-out. Brackets are wide, and you have to be sure that whatever you're having pop out will hide the brackets themselves. So if it's a big solid block of object, it's usually pretty easy to hide those brackets. If it's smaller things like arms and hands and fingers, it tends to be a little bit of a problem. You can see on the bottom shot that from straight on, the brackets are hidden really well, and it looks really good. But as you start to drive by, you start to see those brackets come into sight. We can also do extensions off the poles themselves, but these do require a little bit heavier gauge support brackets on the back, and they'll need to be welded in place on location. So that's definitely something to account for. And it's also a good idea to put a placement guide on the background if placement is really important. Like on the Miller Lite one, just getting it kind of in between the other bottles or in a basic area will suffice. You really don't need a marker. But if you need an extension to be precisely in the right spot, it's good to put an outline up there so the ops crews will know how to know where to place it and where to attach it. Now the outline was kind of faint on there. I don't know if you were able to see it, so we kind of highlighted it right here. But this one had to, the pop-out had to line up with the background pretty close to keep the illusion real. So we did include that as well. And unfortunately, the Breaking Bad font didn't have a 3 in the as an element or a singular D. So we had to improvise on this. The whole DB is a little derogatory, and it would set off my OCD for the rest of the presentation, so I fixed that. Thank you, Photoshop. Okay, so the last part we're going to go through is the 3D. And what we learned in 3D is 3D means a lot of different things. It could mean clear, transparent bubbles. It could be giant blocks of foam. It could be finely finished, freestanding text, cartoon characters brought from 2D to 3D, panel facades, all the way up to pests. So we really have a loose definition of 3D. So there's three main approaches to 3D. Hotwire, and this is actually done similar to an Illustrator file. Think of Hotwire as things that you can do in Vector, in Illustrator, and cut with a single piece. The other thing is milling. Milling, you can kind of think of this as 3D models and organic shapes. Those have to be milled instead of hot wired. And then lastly, it's the whatever it takes 3D models. And those that's something similar to the transparent spheres that you saw on the previous slide. We don't like to focus in those areas. That's not really what Lamar Graphics is focused on. It's not what we do. We focus primarily on the hot wire and the milling aspect of 3D. That's what we want to do. So in this video, I'm going to show you what the hot wire is and what we mean by it. So this is actually shown at double speed, so it goes a little bit quicker. The hot wire is a wire that burns pretty hot. It's almost like a toaster oven wire that will cut through foam just like hot butter. It runs right through and cuts out any shape on a vector path that you plug into the machine. So right there, it cut an oval. You can see over here, it's cutting the same thing on a thicker block. The hot wire is so hot that it actually doesn't touch the foam, but it actually melts the foam away before it becomes in contact. And that's the finished piece. And these are good examples of what we cut on the hot wire. The DUI is a 3D letter blocks up top. They were all milled straight to, or actually, they were all cut directly on the hot wire, finished and sprayed. This is another example of good projects that would be hot wired. The other process for 3D is the frog mill. So on this one, you can see the mill actually cuts in an XYZ axis. And it's basically just a 3D milling machine, like you would see on some of the how it's made videos on TV. There is a big drill bit running back and forth, cutting through the foam, and that bit is moved back and forth in the XYZ axis. And this one is showing you when we put the R axis, or the rotational axis, into the cutting as well. So the props can be cut in a full 3D round, which worked out great for our totem pole. Now the cutting depth is only about 10 inches on the milling machine, so each one of the props are built in tiles and pieces. So once each piece is milled out, we use the hot wire to release it from the foam blocks. Now you can see us assembling this hard hat prop, and each piece is kind of fit in place, kind of dry fit, make sure the all finishing is done properly and put into place. And once we're sure of the fit, we start gluing it all together. And the sandbags and tape will hold it in place while the glue dries. But the whole process is built just like a big Lego set. Now these are good examples of what milling projects should be. Like this apple, things that are done in the round have to be milled in sections like you saw on the previous video. These are things that definitely can't be done or cut on a hot wire machine, but actually require the third dimension milling. And this one was tricky because we actually started with a 3D or a 2D drawing, a cartoon character, and bringing him to life was an interesting project. Okay, now I want to talk about wrapping and versus painting. So there's two ways to finish 3D models. The first one that we primarily do is the wrapping. Wrapping works really well for geometric shapes, for cars, letters, or photorealistic props. And painting works great for people and faces and complex shapes, things that are difficult to get that vinyl wrap to stick to and to wrap around nicely. Now, the advantage of the wrapping is it will last up to 3 years against fading out in the sun, while paint is only guaranteed for about a year, maybe a little bit more, depending on the application. So here's where we learned that wrapping is tough. So the first time we tried to actually wrap a human face, it was actually very, very difficult to make that look realistic. These were all printed from sampled photos of Bobby Switzer. Since we had his head modeled, we figured that would be the great first step to get that done. Obviously, the first one didn't come out so well, so we tried option 2 and worked that a little bit better coloring, better ways to cut it off, and separate the different individual pieces. So you can see this one of the wrap on going fully around. Very, very difficult. So with those results, we wanted to see what the other option was. So then we painted it with an airbrush to see if we could get better results. And as you can see from these photographs, in this case, we did get much better results from just painting it by hand versus the wrap. Now, airbrushing is great, but you'll never be able to mimic a perfect photograph. So there are some great uses for wraps. And the last part is the coating, or the frog skin, as we call it. The frog skin is a 2-part epoxy that we spray over top of the foam. When it sprays out of the gun, the two chemicals mix, and it creates a hard shell around the foam, making it extremely durable. One of the things we have learned is hail can really do some damage to the harder shells. You can buy the epoxy in different formulas. The first one that we were using was a little bit more brittle. It was a stiff, almost a light tan color. Since we have done some practice we've gotten some practice out there, we realized a different formula would probably be better. So we got this gray formula now, and it's a little bit more rubberized. So in order to make sure that we are doing, we'll create a pretty decent prop that'll stand up to a lot more damage than the previous coating, we took it out and actually we did some ballistic tests one weekend. So we sprayed some foam and went out there and shot it with all different caliber bullets and different shotguns and slugs and buckshot and all that, just to see what it would do. And it actually came out. It held together much better than the harder stuff. And you can see here, this was a 12 gauge slug that went through, and it barely made a mess. So we're using a much better, more sturdy formula. Now for the hardware, how these things are attached to the board. How we do this is we have 6 to 8 inch timbers that we drill holes through, and we have put all thread attached to them. So we'll sink these in, countersink them into the foam, and use an expanding glue like Gorilla Glue, and that holds a very tight seal around there. It makes it very difficult for that to be pulled out. The shear strength is really, really strong. So each prop is set up to whatever size, or it's cut to a custom length, and depending on the prop is how we set the hardware up. So on this was the Pepsi bottles that we saw earlier, and this was embedded with the 8 inch, the 2x8s with the all thread inserted. Now we cut these things and build the hardware custom for every application. So depending on how it's done or how big it is, will determine how many pieces of all thread and how many timbers are inserted. Once they are inserted, we go to the spraying and the coating. The coating is sprayed heavy over top of the back of these of the hardware. Now this actually adds a lot of strength and rigidity to the hardware, making it even more difficult to pull out, increasing the shear strength. And you can see on the back, this is the big Pepsi bottle as well, and it's sprayed directly over top of that. So depending on what the shape and the size of the prop is, will determine how many attachment points we embed. Now shipping, we have two different methods for shipping as well. Some are pretty small and easily fit on a 4x8 crate, and we can stick them in there, pad them up, and ship them on their way. Or in the case of the Mosquito, the legs came off and it disassembled, so we can send them all. We could compile all the different pieces and stick them all in a crate and send it up there. So the magic size is the 4x8x4. And as long as we stay within that 4x8 footprint, FedEx does a pretty good deal, gives us a pretty good deal on the shipping. Now, anything larger than that can't be taken apart or is built in one seam, like this big Pepsi bottle, those can be freighted or hot shot directly to location. And it does depend on where you are, will determine the price and how far they have to go. But we worked out a pretty good deal with a local hotshot guy here that he travels pretty much anywhere we're willing to pay him to go, and we'll pack it all up and deliver it straight out. Okay, and wrapping up, just to kind of consolidate everything that we've gone over, there's a couple of things I'd like for you to take away. There's some common pitfalls that we see over and over and over that we want to go over and just make sure that you're aware of it. The first thing is all the Lamar bulletins, almost all of them, come with a catwalk. The catwalk is there. It does interfere with with props that extend down into the pole or around the pole or supersized. Just because you can pull it off in Photoshop doesn't mean that it will look right on an actual structure. Sometimes the props have to be kind of cut in half and assembled around the catwalks, or the catwalks will have to be removed in sections or in certain sections just to install that. So whenever you're designing something and it extends way below the bottom of the skirt, make sure that you have at least a little bit of room or account for a seam or something along that catwalk. Secondly, the lights. The lights, they are also there, and they can or can't be removed, but that is something that will obstruct any kind of prop that extends down too far. So please account for that when you're designing for them as well. And the stringer and riser location. There's a lot of different structure types out there in our inventory. So some of them are, the metal framework like you see here. Some of them are wooden structures. So that really determines how it's going to be attached to the board, but as well as how many different attachment points are needed depending on what type of structure it is. So that's definitely something that we need to know or to consider when we're building a quote or designing a prop. And here's another one, is knowing your local ordinances, and they vary greatly. This one's a little tricky. We didn't discover here in Baton Rouge until we were mostly done with the prop of the Gordon McKernan one, where it's the big lawyer standing on top of the 18-wheeler. We didn't realize till after the design process was in the process for quite some time that there is a 12-inch rule in Baton Rouge that you couldn't extend below the bottom of the billboard more than 12 inches. So the skirts themselves will go down 24 to 36, but no extension can come off any further than 12. So we ended up having to modify the truck and trim off the bottom of the 18-wheeler's wheels. So that was a little inconvenient. We weren't planning for that, but that is something that came up. And also in Texas, there was a time there that they were trying to push for extensions, and including 3D in that as well, that it can't be more than 15% of the total board square footage. That can be pretty limiting, especially with some of the larger props that we're doing now. And there was a little back and forth as to what constituted the 15%. Was it a frontal square footage of 15% of the board, or were they taking the depth into account as well? because if they take the depth into account, the prop actually has to be much smaller than that. So I don't know if that issue has been resolved yet. A lot of these ordinances haven't been written in for 3D yet. Most of the things on the books pertain to extensions and 2D embellishments. So we're kind of breaking into a new category here, so there may be a few little bumps in the road. And here's a rough sizing guide for the 3D props. I just kind of want to let you guys know in comparison, this is a ballpark, and every prop varies a great deal, but it's a good idea to at least have an idea of what these props cost. Now, this is a standard retro poster, so if you can imagine these blocks, these 3D areas in relation to those prop size, or into the board size, this will give you an idea of about what you're going to spend on the props. So a 10.6 by 36 up here, with the largest prop being closer to 12 grand. And what the $3,000, $8,000, and $12,000 ones look like on 14 by 48 here. And if you want to use a prop that covers half of a 14 by 48, you're going to have to spend some cheese on that. So keep that in mind whenever you're pitching these ideas. Kind of keep this rough guideline for a size guideline in mind whenever you're designing that. Keep your clients' budgets in mind. And quoting does take us a little bit of time, and I'm just going to show you why that is. A lot of people will send in a quote, hey, how much is this? Can you give me back an email or an answer in a few hours? Well, we would love to be able to do that, but the quoting process takes a little bit more time. So we ask for a couple of days, and this is why. Most of the quotes come in just through an email, say, here's my design. Can you get me a price on that? We meet every morning at 9 a.m. So that's the whole 3D team. Me, Charlie, Jody, Randy, Roy. We all kind of pile up and brainstorm each one of these things because we all represent, a different area in the process. First thing we ask is, can it be done? And if it can't be done, what can be done instead? So we don't want to just come back with a no. We want to come back with a no, we can't do that, but here's something that we can do. Then we determine if the prop needs to be milled, wired, or both. And should this one be painted or wrapped? Which one would be more cost-effective or more realistic? And then what kind of structure is this going to go on? Is this a wooden structure? Is it a metal structure? Is it a retro? Is it a bulletin? And then how are we going to ship it? What size is it? Can it be taken apart? What are our concerns in that area? And then how do we attach it? What angle is it going to be attached at? Are there enough attachment points? Is the prop thick enough to embed the hardware? And does it light up or move? Because we can do some special effects as well. Then we consider what part of the country this is in. Should we plan for hurricanes, snow, or tornadoes? How sturdy does this thing have to be attached to the structure? And then once we have all that information, then we start laying out the materials. How many blocks of foam? How much square footage of frog skin? How much of the graphics or paint or hardware? What all the special effects are going to be? And then we have to compile all those numbers and get a realistic quote back to you. And then we send you the quote. So that process can take anywhere from a day to sometimes 2 or 3 days to track down special hardware needs or attachment points. And if you have any questions, or if you want to get a quote, or you want to check on your current prop, everything goes straight to Jody. So call Jody, and she'll be able to hook you up from there. She's the gatekeeper. She doles out all the works, and she takes care of all the orders. If you have a question, she has an answer. Thank you very much.